Okay, so if we have a quick look at these, so most of the graphs that we've been drawing most of the time have been continuous graphs, except when we went to hybrid functions. So hybrid functions were these ones where you had like a f of x equals, and then you had an equation here and an equation here. Remember drawing those ones for certain values of x? And that's what these ones would have looked like. Okay? These ones here, we've drawn hyperbolas before as well. Now, if it's continuous, it means it has no breaks. So all of these, let's have a look. It has a function, means it has a break or a hole or something in it. So this has got our asymptote down here and an asymptote down here. So basically from this end, if I was starting from here, can I get all the way to the other end and follow the graph without a break? So if I start here, I'm going down there. Then I've got to actually lift my pencil off or pen and go to here. Yep. So if you consider, if I have to take my pen or pencil off, then it's discontinuous. So thinking about that, if I start at the start of this graph and go like that, I just get to the end, it ends here. So is this continuous or discontinuous? Continuous. It's continuous because I can draw all the way through. Okay, just because it's got that there, I can still go all the way to the end, from the start to the end, without lifting my pen off. This one here. It's discontinuous. I start here, get to there. I've got to lift my pen off to get to there. So it's discontinuous. Now these sort we have not talked about, okay? This means that for some particular value or for some particular point, for some reason, you're not allowed to have that point. So if I start here, I've got to go to here, I can't be at that point. That's a hole in the graph. So then I've got to go to here. So actually from there to there, I've got to lift my pen off. Officially I could draw that circle and then go back, but that symbol, that hole in the graph means it's a hole, it can't be at that point. Does that make sense? So if I was going on my graph, my curve, I've got to go from there, I've got to lift it off and then go to there. So, continuous or discontinuous? And obviously this one, it's got a lot of holes in it, so it's discontinuous. Now, how is this related to limits? We have to, besides saying non-mathematically, we're saying it's got a break or a hole in it. We use limits to talk about how we can prove it mathematically, okay? Saying that I keep my pen on it or I have to lift my pen, that's a way to remember it, but it's not the mathematical way. Does that make sense? So now we've got to look at the mathematical way of actually describing that, and that's where limits come into it. So, if I get an example up. There's two ways we could go about this. I could actually get there, draw a graph, and prove it by having the graph drawn, okay? That's what we did in first term. We did graphing of these hybrid functions, or piecewise functions, okay? But we can use limits to help us, okay? So it's like a shortcut to find out whether it's got a break in it like this, or if it's continuous. So if I look at this, this is x is greater than 1, this is x is less than 1. if it's greater than 1, it's coming from this side, isn't it? So if you think about, if I've got a number line, this is x equals 1. So this is my point 1 on that. X is greater than 1. Okay, so if I do this in orange, it's that way. So if I was to draw that on a number line, that's like that, isn't it? This is to the positive side, or to the right hand side. So if I say the limit as x approaches 1, so I'm approaching 1 from this side, the right hand side, I put a little plus there. Okay, so it's approaching 1 from the right hand side. So it means I'm not putting in 1, but I'm putting in 1.0001. Remember, that's what limits were about. So we approximate it. So that's this side, okay? So I find the limit of x squared plus 2. This is what we did earlier on. So can anyone tell me what the limit as x approaches 1 would be for this one? Yep, yeah. Put in 1, so it becomes 1 squared plus 2 equals 3. Yeah. So, the limit as x approaches 1 from the right hand side is 3. So now I'm going to do it from this side. So I'm going to put it as a whole and put it that way. So this is x is less than 1. Yep. So I've got x is less than 1. So I'm going to do the limit as x approaches 1, but from the left-hand side, so I'm going to put a minus there. So it's not minus, this is saying from the left-hand side, this side. Okay? So it's approaching 1. So this is to the right hand side, the negative there just means it's to the left hand side. So what value would I be subbing in there?
1.
You'd be subbing in 1, but what's the limit value? If I was subbing in 1.0001,
Like negative
0.99999. Can you see that? It's a little bit less than 1. So this is a little bit more than 1, this is a little bit less than 1. So this is like subbing in 0.99999. And this is this equation here, so minus 2x plus 1. So what's my limit going to be there? So it's going to be negative 2 times 1 plus 1 is negative 1. So, what this is saying, if I go from this side, it's going to approach 3. If I go from this side, it's going to approach negative 1. So that means we're going to have a graph that's going to be 3 at one end and negative 1 at the other end. So my two endpoints are going to be up there and down there. So if I had my graph, it doesn't matter what my graph looks like, at x equals 1, this side is going to be up here at 3, and it's a parabola of some sort, so like that. This is going to be at minus 1, and that's a straight line, negative gradient, and that's going to have a hole there. So this would be negative 1, that would be 3. So this is, I don't need to draw the graph either side, it's just looking at this point of 1. Does that make sense? It's coloured in there because of that. It's open because of that. I'm looking at it from this side, the right hand side, and if I take my limit, I get it equal to 3. No asymptote on this one. We're not talking, asymptote was only on this one. This is another discontinuous function. But the ones we'll mainly be looking at are ones like this.
Do you have to graph out the whole thing? Can you just
No.
say the arrow has
You do not have to, this is the thing, limits are saying, a shortcut, you don't have to graph it. Unless it says graph it,
Wait, do you have to say the limits though? Or can you just see if the arrow doesn't have to be a line?
no. No. Because it might work out, if these two were the same values, if this ended up being 3, then it means that it's joined up. Yep? So finding out the limit. So if this ended up being equal to 3, then they would be at the same point, so it's continuous. Does that make sense? So if it's not at the same point, if these ones are different, then it's discontinuous. So, and that's how we finish off the question. So we finish off with a sentence, probably might be able to fit it down here. So since at x equals 1, the limit, oops, that should be 1 in there. Oh no, leave it as the x. It's the limit, sorry. So we've got that limit from the right hand side, limit from the left hand side. They've got different values, so therefore it must be discontinuous. You don't have to draw this graph. I only draw this little thing here for your understanding. So it's that, and finishing it off.